Alright, so here we're going to look at another perimeter and area type problem. So in the figure, four identical triangles, such as the triangle GEF right here, so I have four identical copies of this triangle being cut off from this large square ABCD to form the following shape right here. And the shape is in shading white here. And it is also given that the side angles of AB and FB are the same and they are equal to 7 centimeters. EF is equal to 10 centimeters and G is equal to GF, which is equal to 13 centimeters. And then we need to find the perimeter and the area of the shape form. First, let's start off with the perimeter. Now notice that the four triangles here are actually congruent or identical, meaning that their corresponding side lengths must also be equal. So this is equal to this, this is also equal to this, this is also equal to this, and etc. Which also makes these four sections right here of the shape also congruent, which means that this side length right here is equal to this side length. Otherwise, it will make the four triangles not identical. One can check that. So notice that all these outer small segments, they are equal to 7 centimeters. So basically the perimeter right here will be just 7 plus 7 plus 13, also plus this 13 right here. So let me just write 7 plus 7 plus 13 plus 13, and don't worry, I will write the dimensions later. However, notice that we're just basically repeating this calculation 4 times for each of these sections right here, so we can just multiply the whole thing by 4, leaving us with a final answer of 160 centimeters. Now for the area. For the area, it will be just the area of the initial square minus 4 times the area of one triangle here, as said in the question, because the shape here is formed by cutting 4 identical triangles from a large square. So that's how we get this little formula here. Next, we know that the side length of the square will be 24, so the area will be 24 squared, minus 4 times the area of one triangle, which will be half times its base 10 times its height. Now one can find its height by noticing by the Pythagorean Theorem. Notice that this is just an isosceles triangle, so we can just draw a perpendicular bisector to this base right here, which can be easily found by the Pythagorean Theorem. Or one can notice that G here is actually the very center of this square. So hence we can say that the height of this triangle right here is actually half the side of the square, which will be a half times 24 or 12. Either way works. So hence, leaving us with a final answer of 336 centimeters squared, which ends this video.